Periodicity. The variation of certain properties in the periodic table is called periodicity. These properties include ionization energy, electron affinity, electronegativity, atomic and ionic radius. Ionization energy. This is the energy needed to remove 1 mole of electron from 1 mole of atoms in the gaseous state. It can be rated as sodium losing an electron to form a sodium cation. Electronegativity is the energy change that occurs when a gaseous atom acquires an electron to form a univalent negative ion. Chlorine atom gains an electron to form an anion. Electronegativity is the power of an atom to attract electron to itself when it is in a molecule. Let's consider the first illustrative example. The value of electron affinity of the elements in the periodic table, consider the options. A. Increases than the group. B. Increases across the period. C. Decreases than the group. D. Decrease across the period. Now let's consider option A. They said increase than the group. It cannot increase than the group because as you go down the group, the size of the atom becomes bigger. B. Increases across the period. Yes, as you move across the period, the size of the atom becomes smaller and the effective nuclear charge increases. And so it has that ability to attract electron to itself and form a negative ion. C is not the correct option. It says decrease than the group. It cannot decrease than the group because as you go down the group, the size of the atom becomes bigger. Of course, the screen effect also increases, so it cannot be C. D, decrease across the period. It does not decrease across the period because across the period, the size of the atom decreases and the effective nuclear charge increases. So we don't expect electron affinity to decrease across the period. And consequently, the correct option is B, increases across the period. Now, let's consider the second example. Elements in the same group in the periodic table have the same number options. A, of electrons in the outermost shell. B, of electrons in their inner shell. C, have the same number of shells. D, the same reactivity. Let's consider the options one after the other. A, of electrons in the outermost shell. That is true. All elements in a group, they have the same number of electrons in the outermost shell. That is why you have members of group 1 have 1 electron in the outermost shell, group 2 have 2 electrons in the outermost shell, group 3 have 3 electrons in the outermost shell, and so on. B, the same number of electrons in their inner shell. No, the inner shell differs. For example, some inner shell may have a duplet of electrons, while others may have an octet of electrons. C, have the same number of shells. No, it is only elements in the same period that have the same number of shells. D, the same reactivity. The reactivity cannot be the same, it can only be similar. And consequently, the only correct option is A. Example 3. The values of electron affinity of the elements in group 7 are, let's consider the options. A, the highest. B, the same. C, the highest. And D are similar. Now let's look at it one after the other. A, the lowest. No. Elements in group 7 have a very high tendency to gain electrons and form a negative ion. And so A is not the correct option. B, the same. They are not the same because each of them have different ultimate number of electrons, either a complete duplet or a complete octet. C, the highest. Yes, it's the highest because members of group 7 have a very high tendency to attract electrons and form negative ions. D are similar. They are not similar. And consequently, the correct option is C. Let's consider example 4. Atomic sizes of elements in the periodic table A increase across the period. B decrease across the period. C decrease down the group. D is regular down the group. Let's consider the options one after the other. A, increase across the period. Atomic size does not increase across the period because as you go across the period, the effective nuclear charge increases. That is, the force trying to attract the electrons in the shell to the nucleus increases. And so A is not the correct option. B, decreases across the period. Yes, as you go across the period, the effective nuclear charge increases. That is, the force trying to attract the electrons to the shell increases. And consequently, the atomic size decreases across the period. C, decrease down the group. The atomic size does not decrease down the group. It's all down the group, the size increases because you have additional number of shells. D is regular down the group. It's not regular because as you go down the group, more shells are added. And so the correct option is B. Let's consider the fifth example. The ionization energies of elements in a group A are always constant. B, increase down the group. C, decreases down the group. D are very similar. Let's now consider the options one after the other. So the ionization energies of elements in the group are always constant. They cannot be constant because the energy needed to remove the atom's electron from the atom. As the size of the atom increases, the ionization energy decreases, and so we don't expect it to be constant. B, increases down the group. It does not increase down the group because as you go down the group, the size of the atom increases. And so the ionization energy cannot increase down the group because the further the electron is from the nucleus, the easier it is to remove the electron. D, decreases down the group. Yes, it decreases down the group because
the C, it's not D. It's not D, it's C.
C, decreases down the group. Yes, as you go down the group, the size of the atom increases and the effective nuclear charge also decreases. So it becomes easier to remove an electron from the atom. D are very similar. They can't be similar because the size of the atom differs. The only correct option is C. Now, example 6. Which is larger in size, sodium metal or sodium ion? A, they are the same. B, sodium is larger. C, sodium ion is larger. D, they are the same. Let's look at the options one after the other. A, they are the same. They can't be the same because a sodium ion is formed after an electron has been removed from a sodium metal. B, sodium is larger. Yes, sodium is larger because when an electron has been removed to form a sodium ion, a shell has been removed. So while sodium metal has 3 shells, sodium ion has only 2 shells. C, sodium ion is larger. It cannot be larger. Sodium ion has just 2 shells, but sodium metal has 3 shells. D, they are the same. They are not the same. A sodium metal has 3 shells, while a sodium ion has just 2 shells. And so from the explanation, it can be clearly seen that the sodium metal is larger than the sodium ion. And consequently, the correct option is B. On the list, example 7. Which is larger in size? Chlorine atom or the chloride ion? Options. A, they are the same. B, chlorine is larger. C, chloride is larger. D, they are similar. Now let's consider the options one after the other. A, they are the same. They are not the same because for a chloride ion to be formed from a chlorine atom, an electron has been added. And so the size is slightly larger because of the slight increase in the repulsion between the electrons. B, chlorine is larger. Chlorine is not larger because when an electron has been added to chlorine to form a chloride ion, then the size of a chloride ion should be larger than the chlorine atom because of the increased repulsion within the electrons. C, chloride ion is larger. Yes, this is larger, slightly larger than chlorine atom because that an electron has been added, meaning that the number of electrons has increased, and so the repulsive forces have also increased. That makes the chloride ion to be larger. D, they are the same. They can't be the same. For the moment an electron is added to a chlorine atom to form a chlorine ion, then their sizes differ. So from this explanation, the only correct option is C.